let's see here. Who's in? Cool. All right. Well, that being said, hello everyone. My name is Kevin Kleppe. This is going to be training on the basics of 3D printing and 3D modeling. A couple of things to get started with before I actually get into the presentation itself. One, if you have any questions on any of the things that I covered today, you can always reach out to me either by my email, kevin.kleppe@csusb.edu, or give me a phone call at 909-537-4345. Leave a voicemail, I'll get back to you as soon as I can. And then the QR code that's way too big on the right side of the screen, that'll take you to a link that basically is just this exact same PowerPoint slide. So if you're ever like, oh wait, what was the thing he was talking about on slide 3? What was that one picture? Blah, blah, blah. This QR code, you can scan it and it'll take you to a copy of this that you can view basically whenever you need. Then let's see here. What else do I need to cover before I get into this? Cool. All right, let's go ahead and jump into it. So as I said, this is going to be covering the basics of 3D printing, what it is, how to get started, some of the practical things that we've been able to make as a campus to kind of help out our operations, some of the silly things that we've made to kind of help out, maybe not the operations, but just make something cool that people like. Me, myself, I am Kevin Kleppe. I am the assistive technologist for the campus. My job, my main job is assistive technologist. I do assistive technology for the campus, which is basically IT support, but for folks who are, who may or may not have a disability. So basically I'm the guy that says, try restarting your computer, apply updates, see if that fixes it. And also if someone is low vision, legally blind, has physical limitations, it's my job to try and figure out how to make their life a little bit easier with some of the solutions that exist on your computer. And it's gotten really, really good over the years. And one of the things I've really enjoyed about this job is I find out about stuff like this and I get to think to myself, how can I take something like this little $180 3D printer and use it in my field to help out my users? We've been able to make some silly things and we'll be giving those out at the end of this, such as Pokemon. Everyone's got some phone holders in front of them right now. But we've also been able to make practical things that have made like a genuine difference for this campus, not just for our operations, but it's also saved us a lot of money. So I'm going to be talking about how do you get started. It's going to be very high level. No one here is going to be an expert by the time I'm done with this, especially not me. I'm learning new stuff about this stuff in this area all the time. And also try to hopefully get at least one person who's either here or on Zoom or watching this in the future interested in this and realize, oh, this stuff is like not that hard. It's not that crazy. I just need to have someone like show me the basics of it. So this is actually the very first thing I ever made like that had a purpose. The very first printer I ever got, my boss gave it to me and he said, if you can figure out how this thing works, it's yours. And he just gave it to me. And I remembered coming in kind of like a few weekends in a row just to be like, I want to figure out how this thing works on my free time because like this stuff was just like fascinating to me. And I had my user, one of my users that I was working with at the time, his name is Cameron. And Cameron is blind since birth. And Cameron was having a hard time. Well, everyone recognizes this, right? Yeah, that's our campus. So this is a tactile model and a map of the campus with, as you might notice, some rail markers. This was before the North SMSU was added to the campus. For Cameron, it was made with him in mind. Cameron was really, really struggling with figuring out like how to get from the commons to the rec center or the rec center to the mailroom or how to get from point A to point B on campus on his own because he's blind and his campus kind of wasn't designed with him in mind as a lot of different locations were. So he came to me and he said, can you make a map of the campus or can you make a map of my dorm room in my dorm area so I can know how to get mail, do laundry, go to the commons independently? And I said, give me like a month or so and I'll try to figure it out. And we ended up being able to make this thing for him, where I remember actually being able to put this thing in his hand. I have not the exact one, but like it's basically the same file right here. Putting it in his hand, me like, I have no idea if this is gonna work or not. And him going to, I think he lived in this one. I think he lived in this particular dorm right here. And him saying, oh, there's a pathway to get the jack around here. I didn't know that. I was going this long way around this whole time. I didn't know that this particular path existed this way to get to the bookstore. History lesson bookstore used to be way over here, kind of like in the front of the campus, and now it's in like the SMSU North. And I actually got to make and have that experience of showing this kid like, hey, here's what the campus looks like. Here's how you can actually like navigate and get around on your own and independently, which is really, really cool because I had never done something like this before. I also had no idea if this was going to actually work. This thing also paid for a conference trip, which was also really, really cool. So there's a lot of cool stuff happened from like this one idea, and everything I've made since then that's kind of resulted because of this. Really quick, any guesses what my bachelor's degree might have been in? Isaac, right? What's your name?
Marlon.
What is it?
Marlon.
Marlon, what do you think my bachelor's may have been if you were to go off of this? Music. Political science. I was a political science major in my bachelor's. So as you can imagine, not exactly a whole lot of training to figure out how to do this kind of stuff. As a matter of fact, no training whatsoever. And the reason why I bring that up is I want people to see this and be like, oh, if a political science major can figure out how to make this thing, like anybody can make this, because that's how easy it's gotten in the last couple of years. So that's what this presentation is going to be about. How do you make practical things? What's the overall process of actually getting started with stuff? And what are some of the silly things you can make, the practical things that you can make? And at the very end, we'll have a couple of giveaways to give out for folks. And then if you haven't already, if you're in the room, if you're not in the room, you're missing out because there's pizza in the back. Feel free to grab a slice whenever you want. And like if I'm talking, just go for it. So this presentation is going to be about one, the very basics of 3D printing and 3D modeling. How do you go from idea to actually like starting to map this thing out to actually making the thing into like a real world item? Again, no one is going to be an expert by the end of this, but I want everyone to at least kind of have a basic idea and then show some of the different practical things that we've actually made. Let's see here. Very basic 3D printing. 3D printing files we find, blah, blah, blah. Let's do this. So to get started, there are 3-ish steps to 3D printing. One, you got to get the model somehow. You got to actually get like that actual like 3D model somehow and actually put it onto your computer so you can actually start the process of the next step, which is slicing the model. Slicing is basically you taking that model, whether it's something you made or something you found or something you got from somebody else, and telling your printer, this is how you're going to take this 3D model and actually turn it into a real physical world object. So I kind of think of it like you guys know how like there's like the artist rendering of like a building of what it's supposed to look like, and it's very shiny and cool looking. And then there's like the actual blueprints of the building, kind of like how like everyone knows like that huge construction project that's happening, right, with the performing arts building. So they have like the artist rendering of what it's supposed to look like. It's this big, beautiful thing. And then there's the actual like blueprints of what it's supposed to look like when it actually gets built. The first step of this is kind of like the artist rendering of this is what we want it to look like when we want to get it eventually done. And then the second step is this is what the actual blueprint is of like your model actually going through the 3D printing process. So a model, that's just like the 3D object that you get in like Blender or Tinkercad or like wherever you might get it from. And I'll quickly go over those in a second too. And then in the second step, and I'll show you what this looks like too, is you actually going into your computer and saying, this is how I actually want to make the thing into a real physical object. So, and then the third step is just printing model. So Marlon, what are the 3 steps? Perfect. It's like it's right there on the PowerPoint slide. So really quickly, what do I have here? So one, get the model. There's a million different ways that you can do this. Either you can do it the really easy way, which is just, you just go online and you just type in whatever the object is that you have in mind and type in STL. So does anyone here have something in mind? They're like, oh, I want to try and make this. Like when I'm done with this, like, does anyone have anything in mind? You're just here for the pizza or what's your name? What's your name? Robin, very nice to meet you. Is there anything that you're like, oh, if I knew how a 3D printer worked, like this would be the kind of thing that I would like to make, whether it's like, I don't know, silly, like Pokemon thing or like car parts or like, what would be something that you would want to make? What kind of animal did you have in mind? Like a robin?
Yeah.
Okay, hold on. Robin, STL. It's Robin from Batman. Okay, we'll go with this for now. But this is how easy it is to actually go out and just find the model itself when you're like thinking about what you want to make. You can just literally type in whatever the object is that you want to make and just type in STL And you're gonna find a million different websites that actually have that thing like already there. So if I were to do Robin the bird STL, again, you're gonna find a million different websites that have just like this thing freely available, and you can just download it today and actually, oh, we don't want to do that. It's $10. Hold on. Let's do this. What's a free thing we could do? Yes, I'll accept cookies, fine. Basically whatever it is that you might want to try and make or whatever you have in mind, you just need to type that object in, STL, into your Google, like your favorite search browser. And you're gonna find a million hits on like what that thing might actually be, and find like a million files that someone has actually gone through and done the hard, dirty work of designing this thing that you can just download today. So the other way that you can do it is you can just make that object yourself. And there's a lot of different ways you could do it. The number one easiest way I've done it is with something called Tinkercad. So Tinkercad is just a free website. I have no idea like how they actually make money. I've looked for ways to like give them money, because like, this is an amazing product, like let me pay you something. And you can just go to this website and start designing stuff on it for free. It's very easy, it's very intuitive. So just another silly example. I don't have any right now, but like you can make 3D printed business cards with this thing. So what's your name? What is it? Iris, very nice to meet you. Let's say you wanted to make a business card, you wanted to 3D print something, like a 3D printed business card. What you can do, and this is Tinkercad, this is free, you just sign up with whatever your personal Gmail account is or whatever your personal email is. You sign up, you say create new object, new 3D design, and I actually just do this from the beginning. Gallery of things, Tinkercad, create 3D design. What you can do is in this workspace, everything that you see on the right side of the screen, these are just objects that you can drag into the workspace, and you can modify them and manipulate them in whatever way you want. So if I wanted to, what I could do, just take the little box icon that's on the far right, drag it onto the workspace, take this guy, just squish it down to like 1 millimeter or something like that, and then stretch it out. And then we'll say that's about business card size, something like that. Then I can go back into the object side, take the text icon, drag it on top, and I'm just assuming IRIS, right? IRIS. Where's it going? Hold on a second. IRIS. And then same thing with this guy, you can just shrink him down, make it so that it actually fits on top of it. And then let's line this up, make sure this thing actually like lines up with itself. You can actually put it in like the middle of the card itself. Then you can actually just go to like whatever, like qrcodegenerator.com, turn that into like a 3D object, put it on there, and now you have a QR code business card that you can just 3D print off of like whatever machine you want. This stuff is like really intuitive and easy. Like it's a little intimidating the first time you're like, what do I do with this blank workspace? But the second you actually have like an idea in mind, like it just goes from there. Like you don't really need a whole lot of experience, like a political science major, to get started with this kind of stuff. So there's the easy way. Yes, what's up? You could do import. So if you wanted to do an image, there's a couple of different ways you could do it. You could import a something that's known as an SVG file. So if I wanted to, one second, do I have it here? I do. This is a bad example because at the very end of it, it got smushed a little bit. We can pass that around though. So what I did for that guy is I went to whatever like QR code making website, and I downloaded the PNG of that QR code. And then I took the QR code PNG and I took it into, what was it? PNG, let's see here. PNG to SVG converter. And on one of these websites, you basically just say, hey, this QR code that's in black and white, I want the white sections of this to have a height of 0, and then I want the black sections of it to have a height of 1. So that way you can actually make a 3D model of it and basically just go from there and turn it into an actual 3D object. Did you have something in mind that you were looking to make, or
No,
just curious?
I was thinking of, because it reminded me of my brother, he bought me some like 3D printed like bookmarks. And they were kind of like similar how you showing the they kind of like this, same similar with the business card.
So this is the way that I did it for that, but there's a million different ways that you could do it. You kind of just have to think to yourself, like, what is the end goal that I want to try and do? So for example, again, with the QR code, just download it, put it into one of these websites, and it'll take it, the actual like 2D image, and try to like make it into like a 3D model based off of whatever the settings are that you want for it. So there's a few different ways that you can. Let's do this, and then bloop, and then. So you need to get the model. Does anyone remember the second step? Yes, exactly. So slicing the model. There we go. That is, again, you just telling the printer how you actually want the thing to be made into a real world object. So on this computer right here, anyone recognize this guy? Well, it's right here. Here, this little guy right here. So if you wanted to take your model and make it into an actual real world object, I'll just pass this guy around. And then it'll probably be easier to recognize in person. And then there's the I know, it's so sad to look at. It looks like it like had a lobotomy or something like that. Yes. That is, so you'll know which one is the failed model. So I'm making this thing right now, and on the previous roll, I ran out of filament and then switched the filament. And this is what was left of like the previous reel before like I switched it to this. So it basically just like didn't have time to like heat up the new reel in time. So it's just like knocking this thing to the side, and like it didn't actually get like a good print. There's a million different reasons why a print could fall. But yeah, you can see which one is the fourth little thing. So now you need to actually tell your printer how you want to actually make the model that you just made. So on this printer that I have right now, I'm printing Pikachu from Pokemon. And the way that we can actually tell our printer to make it is with this little program. Hold on a second, where'd it go? With this little program right here. This is a program called Cura. Everyone can see this, right?
Yeah.
All right, cool. Again, this is just another program that you can download. It's free, and it basically gives you just a lot of control over how you want to take the 3D object that you just downloaded or made and turn it into an actual 3D printed real world object. So let me see if I can find the Pikachu. Where did that guy go? We'll do Charmander for right now because he's just right there. So as this guy is downloading, there we go. Let's shrink this guy down, and then let's shrink him down to like 45 or something like that. Right, perfect, cool. So this right now, this is just the 3D object as a 3D object. There's been no conversion of it into an actual like real world printed object whatsoever. Your printer has no idea how to interpret this thing. So with the slicing program, that's when you go through and say, this is how I want you to take this 3D object that only exists in like ones and zeros and turn it into an actual physical object. So you can do that. It's very complicated. Check this out. See the little slice button right here? Just click that, and it'll go through and it'll slice it for you, and it's already done. So now you can basically just take this file that your printer just made for you, and now you can actually feed it into your printer, and your printer takes care of the rest of it for you. So that's how easy this step is. There's a lot of configurations that you can do for it. So for example, if I were to shrink this down, and kind of cut into the different layers that are actually in this guy, you can see like these little honeycomb sections that are in the middle of it. This is called the infill. Infill is basically just like how much of it is actually infill. These things are mostly hollow. One, to save material, but two, to also save print time, because otherwise it's going to turn into a very, very long print. Like maybe you don't want it to be like a 10-hour print or something. You just want like a silly little Pikachu or something, right? So if I were to, and then what was your name? Melanie? Very nice to meet you. So the infill for this guy right now is 40%. If I were to change this down to like 5, what do you think would happen to like the infill that we just saw inside of this thing? Yes.
That's when you're able to share your screen.
Oh, no, that's right. You guys are looking at it through Zoom. Hold on a second. Can we control? Capture on this guy. What does it look like for you guys in Zoom? Bloop, bloop. Oh, that's gonna be real hard for you guys to see. I'm sorry, Olivia. Let me shoot you a message later and I can show you exactly what it looks like from our section and from our perspective. Does that work for you for right now? I don't have an answer for you right now. Is that okay with you? If I reach out to you later?
Yeah.
All right. Okay, cool. I'm so sorry. I did not think about that whatsoever. So do you remember though, like, what do you think would happen if we were to change it from, what was it, 40% infill to 5% infill? It wouldn't be filled in as much. So if I were to click slice right now, and then look at it. So as you can see, this is not going to be a very stable print because there's not exactly a whole lot inside of this guy for this to actually be filled up. And then Marlon, if we were to change this to 100%, what do you think would happen? Yes, it would probably. But then it would also, one, make it a very solid print. So you could like take this guy and toss it and like it's going to be like just fine. But it's also going to turn into a really long print time. So it goes from like, what was it before? Like an hour and 30 minutes to like an almost 6-hour print. And then one last example, and we'll move on to like the last step. Right now, the layer height for this guy is 0.2 millimeters. So that basically kind of determines like how detailed your actual print is going to be. So if you were to lower it, that means all of the different layer lines that are on this thing. So all of you should have like the little coyote phone holders in front of you. Those all have a 0.16 layer height. So if you like really look closely on it, you can kind of see like where like each layer kind of begins and ends. So each of these guys, let me change this back. Hold on a second. Blah, 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 blah. Reset, slice. And then we will, so each of these guys, each one of these layers has a certain height that's associated with it. And the higher the layer height, the less detailed it's going to be, but also like the faster the print is. The lower the layer height, the longer the print time is going to be, but also the more detailed it's going to be. So there's a lot of settings that you can change in this. In most of the default ones that you see on here, infill 20%, quality 0.2 millimeter height, speed 50 millimeters per second, temperature 200 degrees Celsius. You just leave those by default and you're going to be 100% fine. But if you wanted to make this really, really detailed, you can change the layer height of the sky to whatever you might want it to be. So if I were to, let's see here. And then Iris, I'm going to call on you this time. Right now, the layer height is 0.2. If I were to change this to like something outrageous to like 0.6 or something like that, what do you think would happen to the model? Specifically the quality of it and like the print time of it. What was that? The quality would be way worse. So check this out. So we had it at 0.2 before. So, oh, that's not that bad. Let's change it to something really outrageous. Let's change it to like 1 milliliter layer height. So one, it's going to print a whole lot faster, but two, it's going to look like garbage. It's going to look like this. So that's just a very chunky, very like ugly kind of looking thing. Unless you're going for that look, then like this is perfect. And then Robin, if I were to change this to 0.1 layer height, what do you think would happen then? And what else? It'd take a whole lot longer. So let's see how much longer it would take. So I think before it said like an hour and 40. It doesn't even want to slice it. That's how like detailed this thing is. Let me do this. Let me try it one more time. Let me see if it'll work with us. And then slice. It's even taking a long time to actually slice this thing. So it'll go from like a 2-hour print to a 4-hour print, but look how detailed this thing is. It's so smooth. And depending on like what you might actually want for your guy, it'll kind of determine what the settings might be. So everyone recognizes this guy, right? It is, yeah. So that guy was printed with, I think, 0.16 layer height, but it's like really good. Like you can actually see like all the different like crazy facial expressions and like facial features that they have with it. Like when they were designing this character, and like it kind of nailed it, at least from my perspective. Maybe you guys kind of feel differently. But also that guy was filled with 0% infill, so it feels really, really light, right? Yeah, so 0.16 layer height and then 0% infill. So it took a really short amount of time, but it's also really like frail and kind of like weak feeling. But also really, really detailed. And in fact, it's like a perfect like thing to put on your desk, like as a desk decoration thing. So that is slicing the model. Just slice the model, change the settings depending on like what the actual thing is that you want to make, and then press print. So does anyone remember the last step to this whole thing? Melanie? Remember? There's only 3. So we got the model, we sliced the model. Now, if we wanted to print this thing, what would be the last step? I mean that's kind of it, yeah. So now that you actually have the slice file, now you actually need to print this thing. So this right here, this is known as a oh, not an SLA printer, FDM printer, fused deposition modeling. So basically, it just heats up the plastic with the little nozzle that's right here and melts it all together to like make whatever object it is that you want, right? This is great if you want to do like really, really like kind of like cheap, quick stuff. But if you want to get really, really detailed, the other kind of printer that you can do is called resin SLA printing. And I do not remember what SLA stands for. This is the kind of detail but that was made with a resin printer. And just look at like the detail of like the sunglasses and like how small of a part that is compared to like the detail that you're getting with like the Coyote foam holder. FDM printing, which is again this guy, is very, very easy to get into, very, very safe because you're just like heating up a nozzle and pushing plastic through it versus resin printing, which is really precise and really defined, and you get some crazy detail out of it. But it's also very messy, and you have to wear PPE equipment when you're doing it because the material that you're using for it is called resin. And if you get it like on your fingernails, like I've gotten it under my fingernails, it sucks. Like it burns. It's not a good time. So for most folks, if you're interested in this stuff, just get one of these. It's 180 bucks. If you wait for like a deal on Amazon or Creality, you can get it for like 160 bucks. And it's just like you plug it in, you're good to go. And then you can also print with different kinds of material too. So this is PLA, which is just the easiest thing that's out there to print with, versus PETG, which is something that we're actually using for some of the equipment that we have across campus. And I'll talk about that in a moment as well. Let's see here. Any different materials. First layer is the most important because if the first layer doesn't go down well, the resin print is just going to be probably going to fail. It's going to look like that one Pikachu I just showed you guys with like the lobotomy. The whole print is just going to look like that. It's just like a melted like pile of just like garbage. Never leave a print fully unattended. That's just like one of the things that I like to do because I really feel uncomfortable whenever I'm like, okay, I'm going to go start a print and then like go visit my friends over the weekend. And then hopefully the print that I started is like perfectly working fine by the time I get home. I really, really try not to do that. As a matter of fact, I haven't done that in a long time because that's just it's live equipment. Like this thing, as easy as it's gotten in the last couple of years to get into and as safe as it is still live equipment. And if you're going to leave this thing unattended, there's a million different things that could go wrong. But 2, you also need to make sure like you're practicing good safety with it as well. So like not touching the parts like while it's going because it could get caught up in the gears or like the nozzle itself is 200 degrees Celsius, which is like not fun to like grab when it's like on and you forget that it's on. So okay, 3 steps. Get the model, either you make it yourself or like you just find it online. Slice the model, which is basically where you tell your printer like this is how I actually want you to make the thing. And then print the model. Which is like you just tell your printer, hey, print this thing, and like we're good to go. Any questions on those? Everyone kind of understand that? Olivia, does that make sense? I know you didn't get to see the actual like slicing part, but that's also like the least interesting part of it. So I'll reach out to you later with like some more information on that. Everyone good? Okay, cool. Let's see here. The stuff that I just covered right now, that's 90% of the stuff that like you need to know if you want to just go out and like buy one of these things or like borrow it from one of your friends. Also right across, can I see a message? Of course. If you're interested in this stuff and you want to try it out for yourself, one, I'm located in like the pointy end of the wedge. So on the first floor here, that's where I work. But then literally like across from here in the first floor of the library, they have something called the Innovation Lab, where they, one, have a lot more printers than I do, and they're also way, way nicer. So this guy was like $180. They have a couple of printers that were like $1,000. And they'll show you how those things work. They'll let you like find a random file, print that thing, and like just let you have it, and they'll show you all the steps that I just talked about right now. But all the things I just showed you in like the last few slides, that's all you need to know to get started. So even if you're just like like me, a political science major, you don't need much else if you want to just like get started. You just need an idea, some free software, which is free, and then to actually buy one of these things. But you don't even have to buy one of those because you can just like go visit the Innovation Lab and they'll just let you play around with the equipment that they have in there. So the very first printer I ever got was this guy. It was a piece of garbage and it sucked, but it got the job done. It was $180 and it still works to this day, like 3 years later. I've since actually gotten printers that actually cost a little bit more money, and they have just done wonders because they have just a ton of stuff built into them that make the whole process just way, way easier, way fewer mistakes, way fewer failed prints, and the whole experience is just a lot better. But if you want to just get started today, something like this, $180, $160, you're good to go. So let's talk about some of the stuff that we've made that's like quote unquote serious. This right here is probably like the actual like #1 thing that we've made that's actually like made a difference for the campus. So this right here is a $400 switch that's used for some of the poles that we have across the and that being everyone knows the blue poles across campus, right? Like the giant poles that are blue and you hit the button and it calls campus police. Let me see here. And it basically tells them like where you're at. It gives you an immediate line to whoever the dispatcher is. And they know like where the emergency might be happening. This is what the inside of them look like. These are not waterproof. They're not windproof. They're not dirt proof. So when it rains, like it's been raining in like the last couple of weeks, these things are exposed essentially to the elements. These things short circuit, and that's $400 down the drain because this thing isn't properly covered. Excuse me. So I had one of the techs come to me and they said, hey, you got these 3D printers. Is there a way that you can actually design something that goes over it so we can protect these things? And I said, I don't have something like that right now, but if you give me a bit, I can maybe come up with something. And this is what we ended up coming up with. Again, just Tinkercad, a little bit of fiddling around, a couple of failed prints that didn't work out initially. And we were able to make that thing, which we have now deployed to every single blue pole across the campus. So, which is kind of cool because again, that particular thing cost like $4 of materials to make, and now it's protecting $400 pieces of equipment for the campus, and they're actually working, which is really, really cool. Same thing with this guy. This is one of the power supplies that we have inside the blue pole as well. And again, when it rains, those poles are not insulated correctly. So like when it rains, the water just gets in everywhere and a lot of stuff short circuits, including the switch devices, and then the actual like power supply. Hold on, let me actually explain. That's just like, I handed a random thing and it's like, what is this? So this is the actual power supply that goes inside of the pole. And it's like, it's situated in kind of like the back of it. And as you can see, that's not exactly going to survive rainfall. So if water gets inside of it, this thing is going to short circuit, right? So we made these little like umbrellas that basically connect to the pin rail that's right here, protect it from any water that like might actually get inside of it. So again, like $3 worth of material. you're protecting something that it is powering some like really important infrastructure for the campus. Again, this did not take a whole lot of I don't have a mechanical engineering degree. I don't have a design degree. I just have too much free time, and I wanted to help this guy out. So he said, "Can we design something that fits on top of the switches and can protect some of the power supply that we have?" I said, "Give me a little bit of time, and I can try to design something." This is what we came up with. What else have we made? Braille maps. I talked about that at the beginning. This is a really cool thing to be able to help this guy out who was not dealt the best hand of life. And now we actually have something that we can give out to students that let them kind of navigate the campus on their own more independently. Tactile models. This right here is one of my favorite people in the world. Her name is Myrna Campos, and she is a psychology major. And she can basically nail any quiz that you might give to her, or any test. But if you asked her, what does DNA look like? She has no idea because she's blind since birth. So what we were able to do is, again, with one of these 3D printers, is actually make those models and put them in her hands so she can know, like, this is what DNA looks like. So everyone knows like the double DNA helix like model shape, right? She had no idea what that is because it's always been just like an image in like a textbook. And we were actually able to make that, and I won't play the full thing, but let me just cut to, let me see if we can get that exact moment. There it is. So like this moment, she could tell you all the different parts of like DNA and like what it actually includes and like what actually comprises DNA, but she had no idea what like the actual DNA strands look like. With, again, just like a little bit of free time and a 3D printer, we can make a DNA like helix, put it in her hands, and now she gets to know, oh, this is what it looks like. Now I know, like, I'm on the same level as my peers now. We also made, let me see if I can find it. Where is it? I think it was this guy. No, this guy. The original request that she had was the neuron that's in the brain. So any psychology majors, biology majors, anything like that? Anyone recognize this thing? So this is a neuron in the brain. This is the thing that actually like sends signals to like the rest of your body to say like close your hands or like move your foot or something like that. And she can name off every single part of this and say like, oh, the Golgi body, that does X, Y, and Z in like their neuron, or the axon terminal, that's the part that actually like receives signals from like other neurons in the body or in the brain. But she had no idea what this thing actually looked like. And I got to put that thing in her hands and her be like, oh, this is what it looks like. This thing is crazy. It looks like an alien or something like that. So again, just another very, very cool moment of go online. I think I literally just did this. Neuron STL. And I just found, I think this is literally right here. Downloaded this model, put it into Tinkercad, and just started adding Braille. I had to learn Braille to make this thing. But after that, now she actually knows like what the actual like neuron looks like in the brain. So this is, again, just another like quote unquote serious print that we were able to make for a student who just wants to be able to like get the same information as her peers. Zipper tags of like you have someone who has like cerebral palsy or Parkinson's or like limited physical mobility. It basically just makes it so that instead of having to like grab and pinch the zipper on their backpack, they can just like hook their finger through like a hole and like just pull it open. So I actually saw that thing work live for a student who has cerebral palsy, and it was just a very, very cool experience. And then for stuff that's maybe not as serious, phone holders, every single one of you have now one of those. You're free to take that. Oh, you're using it right now. Oh, cool. Yeah. So just a very silly thing, but like we've started making those, and like it's just a fun thing to be able to give out to folks that like is also kind of practical. Pokemon, that's like it genuinely makes me so happy to know that Pokemon is still popular like 20 years later. Like Pokemon came out when like I was the target demographic, and it's like still a hit with like college students, which is very, very cool. A legally distinct statue that bears unintended similarities to Cody the Coyote. So does anyone have like the little resin print guy that I handed out a second ago? So someone gave that to me in the model that, hey, they print it. I could, and then I had another person from Stratcom and Marcom say, hey, Cody the Coyote is technically trademarked, so like maybe don't call him Cody. So this is a Cody-ish statue. Also, if you fill out the survey that we have at the end of this, it's gonna be basically a raffle to get like this guy, because this is the literal last one that I have. A legally distinct statue that bears unintended similarities to Wild Song. So everyone knows Wild Song, the statue that we have, right? If I have it here, where'd it go? Again, just like with a little bit of free time and a little bit of like determination, we are able to take this guy, scan it, turn it into a 3D model, and then just turn it into like an actual 3D print. So like just some like, again, Wild Song is trademarked, so like I can't technically say or even give these guys out. But you can scan it, you can turn it into an actual 3D model and like hand it out to folks, which is again, very, very cool. So again, how much time do we have left? Got a little bit of time. You're not going to be an expert at the end of this presentation. If I were to do another 10 presentations, you wouldn't be experts because again, I'm not an expert on this kind of stuff. But again, as long as you know like those 3 steps of like get the model, slice the model, print the model, you can do just about most of the things that I just showed you right now too. You just need a little bit of free time and a little bit of determination and you can get started with on this kind of stuff yourself. And that's kind of it. I wanted to leave the rest of this up to Q&A and also let you guys grab some pizza before it gets too cold. Some disclaimers. Never leave a print running fully unattended. This is live equipment. It will go wrong if you let it. So make sure you have some way to check in on it. Like if it's running in your apartment or running in like your dorm room or something, to make sure like it doesn't just like catch fire or something like that. If you're printing with resin, make sure you use personal protective equipment because you don't want to get that stuff in your eyes or under your fingernails. And then I hate to end like on a bummer, but I have to because like I actually had someone ask me to do this once. I don't print or make replicas of weapons or parts for weapons or anything like that. Like don't even ask. That includes toys. That includes stuff from video games, letter openers. I had a student who came to me and they said, you know the game Apex Legends, the first-person shooter? I guess there's like some character that throws like shrinkins or like throwing stars at people in the game. They said, hey, can you make this for me? Like, I really like that game and that's my favorite character. And I had to say to them, like, I can't do that. Like, I can't make weapons or anything that's even like close to it. So I hate to end on like that kind of note, but I really, really kind of had to stress that stuff because 1, I don't feel comfortable doing it. And 2, I have no idea what like the rules or the laws are for that kind of stuff. So weapons, parts for weapons, replicas of weapons, I don't do that whatsoever. Again, sorry to end on a sour note, but I have to end on that. Never leave a print fully unattended, wear PPE, and then that's kind of it. Q&A and then prizes. We have a QR code for you guys to scan. This will basically just give us a chance to get some feedback on this presentation, things you like, things you didn't like, and then for you guys who do enter, this one of the lucky few will be able to win this guy, and then like you can just come to my lab and pick it up and like I'll hand it off to you. But that's kind of all I have for you. Anyone? Marlon, 3 steps. What are they?
Find the model, slice the model, make the model.
That's exactly it. So yeah, as long as you guys remember that, like again, know 90% of the stuff that you know to get started with this. You don't need another like 10 presentations or another 10 PowerPoints to like cover the basics because you just learned the basics right now. Get the model, slice the model, print the model. That's all you really need to know. And that's all I have. And then I'll open it up to Q&A if there are any questions, if there are any answers I can give. And then if not, grab some pizza. Thank you for being here. And then, yeah, that's all I got for you guys.